Hello everyone, I'm Yuhan. Today I'll discuss the key pre-processing and the modeling step for the abalone age prediction dataset. The abalone farming and harvesting is important industry and the traditional method for determining the age involving slicing, staining, and counting growth rings under the microscope, which is efficiency and costly. So we aim to use a machine learning model to predict the abalone age based on the physical attributes such as the length, the diameters, the weight, and etc., replacing the traditional method to reduce the cost and improve our efficiency. And this data set is obtained and stored in the Abalone variables, and the Abalone data features extract the physical attributes such as the length, the diameter, height, weight, used to predict the age of abalone, which is stored in the X variable. Whereas the abalone data target extracts the target variables, the rings, which is stored in the Y variables. And the X shape is displays the dimension of the feature data as 4,177 samples and 8 features in the dataset. The number of the missing value for each feature is calculated by the Islam sum, and the result shows that there is no missing value for all feature, indicating the data is complete. The X duplicate sum then counts the number of duplicates in the data, and the result is 0, indicating that there is no duplicate values in the dataset. The X inform shows that there is 4,177 samples and 8 features in the dataset, of which 6 is a category called data, and the rest of features are some numerical data. And subsequently, the auto-wise is used to automatically generate the data visualization to help analyze the features distribution. And the DF describe is calculates the basic statistics such as the mean values of abalone age of the rings is 9.93 and the maximum value is 29. So we use the label encoders to convert the text to the numerical format, where the 2, 0, 1 represents the different categories. Then the Turkey rules to identify the outliers, calculate the interquarters range to set the upper and the lower bounds, and found that the multiple range values are out of range. Finally, these data are removed to reduce the impact on the modeling. Then we use the box plot to visualize the outlier distribution of the rings. Then the separate features variables X and the target variable Y from the DF data frames removes the rings columns to create X and makes Y separate data frames. So for the feature importance part, the first day we use the train set split to divide the dataset into 80% training and 20% testing set. The Z-score normalizing was performed for the X train, X test, Y trains, Y test, and there's random forest regressor models was trained. So from the result of the chart, the shell weight is the most important features. The shaft weight, the shell weight, has a large impact on the target variables, and the sex has a least impact. So today's code tests the variety of the regression models, including the multiple linear regression, the lasso regression, the range regression, the elastic net regression, KSVR, decision tree, and etc. And so from the result of this, we can say that the best model is multiple linear regression and the range regression. The MSE of the multiple linear regression is 5.1 and the R square is 0.53. And the MSE of the range regression is also the 5.1 and the R square is 0.53. The poor model is the last one. It's multilinear perceptron, and it performs the worst with R squares equal to 0, indicating that the data is not fitted effectively. So through the features importance analysis, we found that the shell weight is most important features for predicting the Abalone age, which is accounting for 50%. And the linear regression, such as range linear regression and multiple linear regression, perform well, indicating a relatively stable linear relationship between the age and the certain trait. So through this project, we demonstrate how to use the machine learning techniques to solve the real-world problem, and in the future, we can explore more in symbol modeling to further improve the model performance.